Hi, my name is Sarah Parkerson. I am a teacher at West Feliciana Middle School in West Feliciana Parish. As an educator, I am most passionate about engaging and inspiring my students, utilizing lessons that encourage the students to ask questions, investigate, and solve problems collaboratively through topics that are relevant to their lives. In doing so, I hope my classroom provides equitable learning experiences for each student who becomes a part of Room 216. In this lesson, you will see 7th grade science students using the Open SciEd curriculum. The students will begin answering the lesson question, how do oceans affect whether a place gets a little or a lot of precipitation? The lesson builds towards the performance expectation to develop and use a model that describes how the uneven heating and rotation of Earth causes patterns of atmospheric and oceanic circulation that determine regional climates. In previous lessons, students viewed weather forecasts from the Today Show of several storms moving across the country. The students figured out that these storms seem to move in predictable patterns. This led students to wonder what causes air masses to move in these patterns. We used satellite data from NASA to determine that prevailing winds move air masses from west to east across the country. Through the satellite data, students seemed to notice that these storms were coming from ocean waters. They wondered, how do oceans affect weather? This lesson will focus on figuring out the connection between ocean currents, evaporation, and their effect on these air masses and precipitation. Students will integrate text and media to obtain additional information to clarify how ocean currents that circulate cooler and warmer waters to different latitudes affect air mass, temperature, and humidity. The students in this class are a mixture of regular education, 504, and special education students. To accommodate these students, I have strategically grouped them so that each table is made up of different levels and types of learners. To further assist, the links and documents that students will need to reference throughout the lesson have been posted online to make the materials more accessible. The students who have a read aloud modification or who need further support in reading will meet with me to read the article together. The lesson is a 2-day lesson, so we will wrap up with an exit ticket, but at this point, the students will not be able to fully answer the lesson question. Welcome to Room 216. We are excited for you to join us. So we figured out yesterday that the prevailing winds cause this pattern of movement in air masses. So today we want to kind of come to consensus on some of those ideas that we figured out and put it on a consensus model. And what did you figure out yesterday about where these different temperature air masses come from? Colin? The poles or the equator. Okay, so what type of air might be coming from the poles? Travis?
Cold air.
Cold?
Cold in the poles.
All right, and what type of air might be coming from the equator? Peyton? Warmer air. So if I'm going to add this to my consensus, where should I put cold air coming from? The north up high, okay. So we know that we have some cold air masses coming from up north. We know that we have some warm air masses coming from the equator. How do these air masses move across the United States? Jackson?
West to east.
West to east. And what is moving them west to east? Rustin? The prevailing winds. So the question we were asking yesterday was, are there patterns to how air masses move that can help predict where large storms will form? Talk with your group about the answer to that question. What is the pattern of how air masses move that would help us predict that large storms are going to form here?
Because that's where the air masses are going to be.
Yeah, since the prevailing winds are what move the air masses.
The west and the east, like they meet up and make a front.
Yeah, because the prevailing winds are moving the air masses to the east, and that's going to cause the fronts, which will make the precipitation move from west to east.
Because all the air is moving east, so like that's kind of like pushing down and like making the air, both the airs collide.
Okay, so we know that where warm and cold air collide, that's called a what? A front. And what happens at a front? Precipitation. And so we have this warm air coming from the equator, this cold air coming from the north. They're colliding right here. Now we're seeing these large storms form over here in the east with the prevailing winds moving those air masses towards the east. So Today we're trying to figure out how do oceans affect whether a place gets a little or a lot of precipitation. So what would you need to know about the ocean to see if it's adding water to the air above it? Talk with your group.
They could put like a thermometer on there to like tell us the temperature of the air throughout the day to see if, and like break its connection from the liquid particles.
And then that's pretty good because usually over storms, you know that hurricanes and stuff over storms, like you know how they start out one, and then they keep on getting bigger over and over in the.
That's because they keep getting like gaining warm air and stuff and CCMs because they move over the ocean while stuff is evaporating and adding to it to make it bigger.
Humidity, we used a humidity probe. If the humidity is higher, what does that mean the ocean is doing? Evaporating, adding more water vapor to the air, right?
So I think what the surface temperature of the water would be, so that would make it easier to evaporate per se.
Yeah, or like how much the water is in the ocean, like the feet, the level.
Right.
To see
Because then there might be cold water mixing in with the warm water because it doesn't reach the sun.
What would we need to know about the ocean to see if it's adding water to the air above it? Layla?
The humidity.
The humidity. What does humidity tell us? Colin?
Water vapors in the air.
The amount of water vapor in the air. What's another way we could figure out how we know when water vapor is added to the air, what happens to the water?
It evaporates.
But what happens? Why does it evaporate?
It
It gets heated. So what could we measure in the water? The temperature, right? We can measure the temperature of the water. What would you expect? If the ocean's warmer, what would you expect? Okay. If the ocean's cooler, what would you expect? Less evaporation. So what I have for you is an animation of the temperature of the ocean. So what do we need to look for? If we're trying to figure out how the oceans are affecting weather and why oceans affect weather. Some places get a little and some places get a lot of precipitation. What do we need to look for in the diagram when we watch? Jackson?
The temperature of the specific ocean.
The temperature of the oceans.
Maybe like different areas because some places like near the equator would be warmer than others.
Okay, so maybe we can compare the temperature of the oceans near the equator compared to the temperature of the oceans farther north. I want you to open your notebooks to page 64. And on page 64, I want you to put the title, Ocean Temperatures Observations, and the Notice and Wonder chart. And I'm going to set the timer for about 4 minutes. And you can do some notices and wonders on your own, and then you can kind of start talking as a group like, ooh, I noticed this, I wonder this.
I also noticed that there's like not a whole bunch of like temperature movement. There is some near America, but not a whole bunch where it's like there's blue here and then blue here and blue here, like in different areas. I did notice that eventually, like over time, the yellow and the green started moving across the equator. Oh yeah, I did notice that, which I think would that be like a wave of temperature?
But I also noticed that when the yellow is going across the equator, it kind of turns into red at the end.
Yeah, a wonder I have is why is there not a whole bunch of movement in like the temperatures? Because I saw that the green was here and then it kind of moved up and down like that, but there wasn't like a big change in movement, so that's a wonder that I had.
I also noticed that down by the poles, it was like really cool. Because it was like dark purple.
All right, so what did you notice from this visualization? Riley?
The temperatures in the middle, they're not really changing that much. By the equator, it doesn't really change a lot.
Okay, who agrees with that? All right, Carson?
I noticed that in South America, you can see that the cold water starts to leak into the warmer one.
Okay, do y'all see that where those two different temperatures of water kind of come together, you said near South America? So how could that affect the air above the ocean? Jackson?
I think the air would be warmer because as we discussed in Unit 1 when the sun heats up the molecules on the surface molecules heat up the molecules in the air.
Okay, warmer air, more rising air, and what else do you think is going to be in that air considering the oceans in those areas are warmer? Mason?
Water vapor.
Water vapor, right?
Like the temperature above it's hot, so it might cause the water or the ocean, some of the water in the ocean to evaporate.
Okay. So why do you think the temperature of the ocean, I don't know if y'all noticed, but over time y'all noticed the temperature of the ocean changed a little bit? Not a whole lot, y'all said it didn't change a whole lot, but why do you think it might change sometimes like in the United States? Carson, what do you think?
Maybe the type of season that half of the world is in, because you know how in the summer, the northern hemisphere, there's more sun hitting the northern and the bottom, so it would be colder in the southern, but it would be warmer.
Okay, so in the summer, our ocean waters are likely going to be what? Warmer. And in the winters, our ocean waters are likely going to be colder, right? How do you think this would affect the precipitation in those areas?
When it's warmer, there's more clouds and more rain. And whenever it's colder, there's like less clouds and less rain.
Okay, and we're going to read more about how oceans affect our weather. So at this point, we're thinking warmer ocean waters, more precipitation, cooler ocean waters, less precipitation. When you get this reading, first thing we want to do is identify the question that we are trying to answer. So what is the question that we are trying to answer today? JP?
How do oceans affect whether a place gets a little or a lot of precipitation?
Okay, so I want you to go ahead and write that question at the top of your paper. Remember, if we can identify a question we're trying to answer, it helps us to set a purpose for reading. And then I'm going to have some of you read at your seats, and then some of you come read with me. Even though it is far from the equator, this current constantly causes evaporation to occur, which brings lots of moisture toward Alaska, Canada, and the northwest United States. How do the oceans affect our weather? All right, y'all, you're going to take what you read today. You're going to need your reading and what you summarized and what the key ideas were. And you have an exit ticket. You will need to use multiple sources of information in your evidence. You have your reading. You have what you noticed from the simulation. So you will use both of those sources of information in your exit ticket. The lesson objectives were met for day 1 of this lesson. I used the exit tickets to check for understanding. The students were able to begin making connections between ocean temperatures and air mass humidity, and identifying important ideas about ocean circulation and temperatures that would affect the chance of precipitation in a location. Students were engaged throughout the lesson in discussion about what they were noticing and wondering in the ocean temperatures visualization. They were able to figure out that the ocean waters near the equator are warmer and therefore produce more humidity and precipitation. Students dug deeper to determine the effects of cold and warm ocean currents on the air masses we have been studying. Something I would do differently next time is provide students with a graphic organizer to complete when summarizing the key ideas from the reading that focused on the relationship between ocean currents, air masses, and precipitation. I think this would have been a valuable tool for students to use when completing their exit tickets and on the discussion and activities on day 2 of the lesson. On day 2 of this lesson, students will analyze precipitation data from coastal cities and use what we figured out about ocean currents and temperatures on day 1 of this lesson to make sense of the data. We will then have a consensus discussion that focuses on producing a summary of key ideas and create a cause and effect diagram that traces how oceans are connected to large precipitation events in the United States. Students will then reopen their exit tickets from day 1 and add any additional ideas or information figured out on day 2 to ensure that all students can answer the lesson question, how do oceans affect whether a place gets a little or a lot of precipitation? Thank you for visiting our classroom.